Hey there, in this video we are going to look at how we write the equation of a line given a graph and also how we write the equation of a line given 2 points on a line. So let's start with slope-intercept form. So as a reminder, slope-intercept form is y equals mx plus b, and remember that m represents the slope of the line and B represents the y-intercept of the line. So when we are writing the equation of a line in slope-intercept form, we need two things. We need m, which is our slope of the given line, and we need b, which is the number where the line crosses the y-axis, the y-intercept. Once we have those, then we can go ahead and put them into y equals mx plus b, and we have our equation. So looking at number 1, we have a line here in red. First thing I always point out or look for is the y-intercept. So that's going to be -2. So -2 is our b value on this line. Now notice this line has a positive slope. So I point that out because oftentimes we will get the correct number, but not the correct sign when we are looking at the slope, especially if we have a negative slope of a line. We might say 3 when it's supposed to be -3. So be really careful when you look at a line, make a mental note. Yes, this is positive. My slope should be positive here. That will save you an error when you're actually doing it. So let's take a look at our slope of this line. Remember to find slope of a line, pick any 2 points on the line. I'm going to use these 2 points, and we are going to count our rise over our run. So in this case, I'm going to start at the lower left point here, and I'm going to go up 1, and that will be a positive 1 since we're going up, and then right 2, which will be a positive 2 since we're going right. So rise was 1, run was 2, so 1/2 is our slope. So now that we have our slope of 1/2 and our b, which is our y-intercept of -2, we can go ahead and write our equation in slope-intercept form, y equals mx plus b. So we just plug in for m and we plug in for b, and we get y equals 1/2 x minus 2. Now let's take a look at one more practice problem. So again, we have a line. We're writing the linear equation of this line by figuring out the slope m and the y-intercept b. So first thing I'm going to look at is where does that line cross the y-axis, which will be at the number 3 on this one. So our b is 3 this time. And then I'm going to pick another point on this line. It doesn't matter where it's at, but I would suggest anytime you're doing this, use corner points, meaning use points where its whole numbers are integers, so like 3 and 2. I'm not using somewhere where it's halfway in between or partially through a box or something like that, because that will make it a little harder to count your rise and your run. So you can start from this top left or you can start from this bottom right. I'm going to start on this bottom right. And I'm going to go up 1, which will be positive 1 for our rise because it's going upward. And then our run would be going back or left 3, and that's going to be -3, not positive 3. It will be -3 because it is going to the left from where we started. So our rise is 1, our run is -3. Now, I do want to point out a couple things. As you hopefully noticed when you look at this line to begin with, the slope is negative, so it should be a negative slope. Additionally, if you had started at this point here, we would have gone down 1, which is -1, and then we would have gone right 3, which is positive 3. So we still would have had, it would just be a -1 on top and a positive 3 on bottom. Either way, because it's a fraction, that means division, top divided by the bottom. A positive divided by a negative or a negative divided by a positive. Both of these examples are actually the same slope, 1 over -3 or -1 over 3, because they are negative as a whole, and it's 1/3 ignoring the sign, okay? So that's going to be -1/3. If you prefer, you can also write the negative in front of the fraction instead of up with the 1 or down with the 3. Now, the most common ways to write this you're going to see are either this way or this way. Typically, we don't see the negative on the bottom, but it is not incorrect. I wanted to show you that all 3 of those ways are okay and do mean the same thing. So plugging into y equals mx plus b, we're going to plug in for m and for b. So y equals -1/3 x plus 3. And that is the equation of this line. So now let's take a look at how we write the equation in slope-intercept form again. But this time we are going to be given 2 points that are on a line written as ordered pairs as opposed to a graph. So we are still going to use y equals mx plus b in this method. And m still represents the slope and b still represents the y-intercept. So let's take a look at the steps. And instead of me just reading them to you, I'm going to use them as we do one of the examples. So let's take a look at example 1 down here. We see we have 2 points. If it helps you, and this just depends on how your brain works, if it helps you to draw a quick sketch and see, okay, 1, 3 is going to be about here. And 2, 5, we go 2, up 5, is about here. And just draw a quick sketch of that line. That could help depending, again, on how your brain thinks, but this could help because you can see that the slope should be positive. And that can help just to make sure that when you get down to the bottom and you get your answer, that you have a reasonable answer. Okay, now not necessary, but again, can help you if you're a visual person especially. So we see a line that passes through the points 1, 3, and 2, 5. So with these points here, we can do a couple things. Remember when we wrote the equation from a graph, we needed 2 things. We needed slope, which was m, and we needed b, which is your y-intercept. We need those same 2 things, but we won't necessarily be given those like we were when we're given a graph. So let's start by finding the slope. We've done that before. We know to find the slope, we are going to use the formula y2 minus y1 over x2 minus x1 using those 2 points that they gave us. So it does not matter which ones are your x1 and your y1 and which ones are your x2 and your y2. Just remember your 1s go together in one ordered pair and your 2s go together in the other. So I'm going to go ahead and calculate my slope using that formula. So 5 minus 3 over 2 minus 1. Once I have that, then I simplify the top and the bottom separately. So 5 minus 3 is 2. 2 minus 1 is 1. 2 divided by 1, remember we don't need to write over 1. That really is just the whole number 2. So the slope here is 2. So we know the slope. Now we just need to go ahead and find our b, our y-intercept. So we've done step 1 where we calculate the slope. And we can go ahead and plug that m into that equation. So we know y equals mx plus b. We know that m is 2. So we right now have this equation y equals 2x plus b. Now, step 3 says in that same equation where you just plugged in m, we're going to plug in one of the given points for x and y. So it does not matter which given point, but it's one of those 2 points because that is a point on that line. And we are going to plug those numbers in for x and y because we don't know b. B is 0, b, your y-intercept. We don't know that. We don't have a point that starts with a 0, and then a number. So we don't have b in this case, but we do have a point on the line and we have a slope. So we can use that equation to find b. So I'm going to go ahead and use 1, 3. That will be my x and my y. So we'll have 3 equals 2 times 1 plus b. And that sets us up to now solve for b. So step 4 will be to solve for b because that is our remaining variable. So 3 equals 2 times 1 is 2 plus b. Now, at this point, we solve for b by getting b by itself. So we subtract 2 from both sides. 3 minus 2 is 1 equals b. So that tells us b is 1. That's where it crosses the y-axis, and m is 2. So our final step is to use m and b just like we did when we were given the graph, and we are going to go ahead and write it in that slope-intercept form. So y equals m, which is 2, x plus 1. Notice when we write our final answer, we do not plug in 1 and 3 into x and y like we did to find b. That's just helping us find b, and then we just use m and b to write our final answer. Y equals 2x plus 1. Now let's take a look at number 2, just another example with different points. So again, if you wanted to sketch your graph, you could, not necessary. up to you. So let's go ahead and go back to our first step where we calculate the slope of these 2 points, or the line going through those 2 points. So x1 and y1 and x2 and y2. So then we are going to go ahead and find our slope. We do that by doing 6 minus 4 over negative 2 minus 2. And if you simplify that on top and bottom, 6 minus 4 is 2. Negative 2 minus 2 is negative 4. And then we simplify that further because 2 divided by negative 4 can be simplified to negative 1/2. And again, that negative could go up with the 1, it could go out in front, or it could go on the bottom. It just can't go with the top and the bottom. So there can't be a negative on the top and the bottom. Otherwise, that would simplify to a positive number. So our slope, is negative 1/2. Now we go ahead and move on to step 2. Step 2, we go ahead and put that m into our slope-intercept form. So y equals negative 1/2 x plus b. Either in that same step or in the following step, we're going to use one of the given points. I'm going to use 2, 4, and we are going to plug that in for x and y. So for y, we have 4 equals negative 1/2 times 2 plus b. And at that point, we go ahead and solve for b. So to do that, we're going to start by multiplying negative 1/2 times 2. So we have 4 equals negative 1/2 times 2 is negative 1. And then we still have plus b. Now to get b by itself, we add 1 to both sides. And we have 5 equals b. And so now we have b and we already had m. So now we can go ahead and write our equation in slope-intercept form. Y equals negative 1/2 x plus 5 is the equation of this line that goes through the given points. So now we are going to take a look at a different type of equations. We are going to take a look still at a linear equation, but instead of writing it in slope-intercept form, we are actually going to use what we call point slope form, which we have worked with a little bit with graphing. And we are going to go ahead and use that point slope form to write an equation just like we did in the last 2 examples. So we are actually going to use the same 2 examples, and I'm going to show you this as a second method. So this technically is a little bit quicker if you understand how it works, but for some people, they prefer the slope-intercept form where they plug in, once they find m, they plug in m, they plug in x and y, and they solve for b, and then rewrite the equation. This one follows a similar start. It's a little bit different in the middle, and then it ends the same way with getting our equation in slope-intercept form. So let's go ahead and take a look. As a reminder, point slope form is this y minus y1 equals m times x minus x1. And again, just as a reminder, m is the slope. x1, y1 is just a random point on the line. It is not necessarily the y-intercept like b is in slope-intercept form. So just keep that in mind. So looking at the steps, step 1 is going to be the same exact step as what we just did. So let's start there. We are given the same 2 problems because I want to use them to compare so you can see the process for finding the same equation, just 2 different methods so you can pick which you prefer and which one you are faster at. So let's take a look at this example down here. So we want to write the equation of a line. Eventually, we'll turn it into slope-intercept form, but we're going to write the equation of the line, and it's going to pass through the points 1, 3, and 2, 5. So let's start just like we did previously by finding the slope. So this is our x1, y1, and our x2, y2. Again, you could have swapped the 1s and the 2s from what I did and still get the same slope. So m equals 5 minus 3 over 2 minus 1. I'm going to go through this quickly because we did already do this on the previous examples. So the slope here came out to be 2. That part is the same as if you were using slope-intercept form. We have the slope. Now, step 2 in this method, we are going to plug into slope-intercept form. So in slope-intercept form, very similar to point slope form, but in slope-intercept form, we plugged into y equals mx plus b. We plugged into y, m, and x, and then solved for b. Here in point slope form, we are going to plug into x1 and y1. That's going to be the point, one of the points on the line. And we are going to plug into m, which is our slope. So we already have our slope, so we can actually go ahead and plug that in. So y minus y1 equals 2 times x minus x1. And then from there, we can go ahead and we can plug in our x1 and our y1. Now, I labeled these x1 and y1. Technically, it does not matter if you use 1, 3 or 2, 5, as long as it is a point on that line. So I'm going to go ahead and plug in 1 and 3. Now, be careful here. 3 is y1 and 1 is x1. So they are kind of backwards in terms of the order and where they go in the equation. So just be careful of that. Y minus 3 equals 2 times x minus x1, which is just 1. So at this point, we have everything plugged in that we need to right now. So in the other form or the other method, we then had b left over, one variable, and we solved for b, and then we rewrote the equation. Here we have two variables, but we actually can just work with and manipulate this equation to get it into slope-intercept form, which is y equals mx plus b. So to get it into that form, we want to do two things. First thing is to distribute the slope of 2 to each number or term in the parentheses. So y minus 3 equals 2x, and then 2 times negative 1 is negative 2. Now, the next and final thing is that we are going to go ahead and get y by itself, and we do that by adding 3 to both sides. So when we do that, we have y equals 2x plus 1, and that is the equation that we ended up with. Now, you'll notice that this has fewer steps than when we worked with the last one. Notice on the last one, we did still get the same answer. We started with the same method in terms of finding the slope, but then we had to do a little bit more work to find b, and we had to remember to plug it back in. Whereas with this method, when you plug in your numbers, your slope and your x1 and your y1, you have everything you need to get it into slope-intercept form without having to solve for a variable and then plug things back in at the end. So that's just a quick comparison between the two. Of course, it is up to you what you prefer and what you are quicker with, and I would use whichever method you are quicker with. So let's take a look at this method one more time. Again, in comparison, we're going to do the same problem, but just with this method using point slope form. So remember, our first step is the same. So we are going to find the slope, x1, y1, and x2, y2. So we find the slope just like we did on the last one, or on the previous page, last method. 6 minus 4 over negative 2 minus 2. 6 minus 4 gives us 2. And then on the bottom, we have negative 4. And we simplify that to negative 1/2. So that is our slope. Now we go ahead and in point slope form, we go ahead and plug in that negative 1/2. So y minus y1 equals negative 1/2 times x minus x1. Now, additionally, remember, we are going to plug in our x1 and our y1 into our point slope form. So to do that, we have y minus 4 equals negative 1/2 times x minus 2. And that is our setup that's going to allow us to get it eventually into that slope-intercept form. So to get it in slope-intercept form, remember we distribute that slope. So we have y minus 4 equals negative 1/2 x, and then negative 1/2 times negative 2 is going to give us positive 1, so plus 1. Now, it is not quite in slope-intercept form yet because our y is not isolated. So we need to add 4 to both sides, and we get y equals negative 1/2 x plus 5. And that is our final answer. And if you will take a look back at our previous example, you will see that with the other method, we also got the same equation, okay? So again, it truly is up to you which method you prefer. So just to reiterate quickly, the two different methods we talked about slope-intercept form, and we talked about using point slope form. And remember that both of those are feasible and will get you to the correct answer. It's just depending on your preference, which one you are faster at and which one you better understand. So they both start the same way by finding the slope. And then from there, that's where it differs a little bit. But if you're looking for fewer steps, technically the point slope form method does typically have fewer steps than the slope-intercept form method. So in summary, we've written from a graph, and when we write from a graph, the only way that I would suggest would be to use that slope-intercept form, y equals mx plus b, because from a graph, you can literally pull the slope and pull the y-intercept because it is directly visibly there in the graph. So that would be my suggestion for when we write from a graph. But when we have 2 points that are on the line, then we can use that y equals mx plus b, or we can use y minus y1 equals m times x minus x1. Either way, we will end up with our final answer, our equation of our line given the graph or given the 2 points.